Question 46. Consider the statements with respect to an ideal gas and select the incorrect one. Okay. The ratio of mean speed to RMS speed is independent of temperature. Students, this statement is correct. Mean speed, which is V average, it is given by 8 RT by pi m. Whereas the RMS speed, Vrms, it is given by 3 RT by m. So if we divide these values, we can see that the root T will cancel out. So the first statement is correct. Let us look at the second statement now. Mean translational kinetic energy of the gas molecules at any temperature is independent of the molar mass. This statement is also correct. The mean translational kinetic energy, Ke average, is equal to 3 by 2 kT. So this is also correct. Let us look at statement 3 now. As the kinetic energy of gas increases, the pressure exerted by the gas also increases. This statement is also correct. As the kinetic energy increases, the collisions of the molecules with the walls of the container will take place with a greater force, which will lead to an increase in the pressure exerted by the gas molecules. So this statement is also correct. Let us look at statement 4. Due to collision between two molecules, only the direction of the motion changes, but the individual energies remain the same. Students, the collision between the molecules is elastic. It does not mean that the individual energy will remain the same. It means that the overall energy of the two molecules under consideration will be same initially and finally. So this statement is incorrect. So we have to mark option 4 as the correct answer to question number 46. Let us look at the next question. Question number 47. A 13 gram sample of CaCO3 was dissolved in half liter of 0.1 molar HCl. The solution was made free from CO2 by boiling, and the remaining solution required X ml of 1 molar H2SO4 for complete neutralization. Assuming no change in volume due to boiling, find the value of X. So students, we have two different acids in our system and only one base in our system. So in order for complete neutralization to take place, the total MEQ of base shall be equal to the total MEQ of the acid. Okay. So we have 13 gram sample, so we can convert it into moles. Its molar mass is 100. So its moles will be equal to 0.13. N factor of CaCO3 is equal to 2. And we are dealing in terms of millimoles. So we have to multiply this by 1000. Okay. Now let us look at the MEQs of the acid present. So we have half liter of 0.1 molar HCl. So we have 500 ml into 0.1. This will give us the value of MEQ of HCl. And if we look at the MEQs of H2SO4, it will be X into 1 molar into the N factor, which is equal to 2. So this value is the MEQs of H2SO4. So on simplification, we'll have the LHS equal to 260. The MEQs of HCl is equal to 50. And the MEQ of H2SO4 is equal to 2x. So on simplification, we have the value of 2x as 210. So the value of x will be equal to 105. So looking at the options, the correct answer to question number 47 will be option 4. Let us look at the next question now, question number 48. Consider the statements. On dilution, molar conductivity increases for a weak electrolyte as the degree of dissociation increases. Yes, the statement is correct. The graph for variation of molar conductivity of a weak electrolyte with root C varies as this. So we can see that upon dilution, the concentration value will decrease. Correspondingly, the value of lambda will increase. So this was for the weak electrolyte. Let us look at statement 2 now. On dilution, the molar conductivity of a strong electrolyte is not affected as all, as the strong electrolyte was already dissociated completely. So students, if we look at the graph of the variation of molar conductivity of a strong electrolyte with the under root of concentration, we have a graph which is linear. So we can see that as the dilution increases, the concentration value will decrease, and as the concentration value decreases, the value of lambda increases. So we can say that the statement 2 is incorrect, as the examiner has told us that it is not affected at all. Okay. So statement 1 was correct, whereas statement 2 is incorrect. So the answer which we are looking for in this question is option 1. Let us look at question number 49 now. Select the incorrect statement out of the following. Compounds with F centers are often paramagnetic. This statement is correct. It is a true statement, because when F centers are created, an anion leaves the lattice point. So when the anion leaves the lattice point, it is filled up with an electron, okay, which leads to the compound being paramagnetic. Let us look at option 2. Schottky defect is usually favored by large differences in size of cation and anion. Students, this statement is incorrect. For Schottky defect, the ions have to leave in pairs. So for them to be able to leave in pairs, they should have almost comparable sizes. So statement 2 is incorrect. Let us look at statement 3. Frankel defect does not change the stoichiometry of a compound. True. In the Frankel defect, only dislocation takes place. An atom moves from its lattice point to an interstitial site. So this is correct. Statement 4. Schottky defect lowers the mass per unit volume of the crystal. This statement is also correct. In Schottky defect, ion pairs are missing, so which will lead to a reduction in the mass per unit volume of the crystal. So we have to select the incorrect statement out of the given ones. So the option which we have to mark for this question is option 2. Okay. Let us look at the next question. Question number 50. Consider the cumulative alkenes given below. So we have been given 2 cumulative alkenes, compound 1 and compound 2, and we have to comment on the planes AB and planes C and D, whether if they are parallel or perpendicular to each other. So students, we know that if there are even number of cumulative double bonds, so if there are even number of cumulative double bonds, the compound will be non-planar. So if this compound is non-planar, it means that the plane A and plane B will be perpendicular to each other. Okay. And if there are odd number of cumulative double bonds, so there are 3 cumulative double bonds over here. So in this condition, the compounds become planar. So if the overall molecule is planar, it means that this plane C and planes D, they should be parallel to each other. Okay. So now let us look at the options. Only plane A and B are parallel to each other. The statement is incorrect. Plane A and B are perpendicular. Only planes C and D are perpendicular. This statement is also incorrect. Let us look at the option 3rd. Planes A and B are perpendicular. Yes. Whereas planes C and D are parallel. Yes. This seems to be the correct answer. Planes A and B are parallel, and so are planes C and D. Students, this statement is also incorrect, as planes A and B are not parallel to each other. Okay. So the answer which we have to mark for question number 50 is option 3. So let us look at the next question.